So hello everyone, welcome to this another video of this channel. I'm Abhishek Verma and today you are watching another video of our Spring Data JPA series. In today's video, we are not going to code anything or I'm not even going to open the IDE. Instead, today's video is going to be theoretical one. But believe me, it is going to be very helpful to you, not only for the interview purpose but also for your day-to-day coding. Because in today's video, we are going to see what are the various type of propagation levels in the transactional annotations. What are the various anomalies? So anomalies, as you know, they are going to be the defects whenever you are going to have multiple transactions parallel. Okay, and then we will see that how to resolve those anomalies with the help of the isolation levels. So without wasting any more time, let's directly get started and see how the things are going to look like in our presentation.
So now we are in the presentation, and first of all, let's try to understand what do we mean by propagation in transactional annotation. So this basically means that how multiple transactions are related with each other. You may say that okay Abhishek, it's a bit confusing, but believe me, that's what the definition tells us. So let's try to understand it with the help of this small code snippet. Here, as you can see, we are having two methods. Method A, which contains some business logic, and then it is going to invoke method B. And again, method B is going to contain some business logic. Yeah. Now, currently, it doesn't matter whether it's a part of service layer or the repository layer. It can be a part of anything. But the point is, on both of them, we are having transactional annotation. Now, the question is that, okay, one transactional annotation is related with method A. Another one is related with method B. So, when we are going to invoke B from A, then how these two transactions are going to interact with each other. So that can be decided with the help of propagation. By default, whenever we don't mention any, then it becomes as propagation.required. So that is always going to be a default one. That's why if you remember in the previous video, we didn't mention anything like propagation. We were just simply discussing, and hence also it was working fine because at that time it was making usage of required propagation. Yeah. But beside this also there are 7 different types of propagation. So after this, let's try to understand all these 7 types one by one. For each and every, first of all, we will see the description, what the definition tells us, and then we will try to understand with the help of same example of method A and method B. So the first one is required here. So as I mentioned you, this is going to be the default propagation type in the transaction. Now just go by the name. What it says, it simply says required, which simply means that it always needs a transaction context. That's it. So now let's say that always when we are discussing from now onwards, we will be talking in terms of method B, because method B is going to be invoked from method A. Yeah. And as you remember, on both these method A and method B, we are making usage of transactional annotation. So let's say that when you are invoking method B from method A, now at that point of time, if method A was having some transaction, so I'm assuming that on method A, we were making usage of transactional annotation. Now we are invoking B. So that means B will be getting a transaction from A. So here it will simply keep on using the same. Instead of creating any new, the same transaction will be used. But let's say that method A was not having anything like @transactional. Then in that particular case, method B is going to create a new one. So it is as simple as that, which simply means it always needs one. In case if it is already coming from some another method, it will keep using it. If it is not available, then it is going to create a new one and hence it will use it. Simple. Now let's try to go with the next one. So next one simply says requires a new. So let's simply try to understand by the name, then we will see the description. So requires a new, I hope it simply means that it always needs a new one, irrespective whether something is coming from method A or not. So the description also says the same, that it always needs a new transaction context, which means that from method A, let's say method A was having transactional annotation with some context. Now if a context is going to come to B, then that particular context will get suspended in B. So B is not going to make usage of same context, and instead it is going to create a new one for itself. Yeah. On the other hand, in case nothing is coming from method A was just a simple method. In that case, method B will simply create a new one and will start using it. Yeah. So this is how it is going to work. Then next one is supports. So for supports, let's say what it says. So it says it doesn't needs a transaction context as such, but can support one. So it simply says that I don't need any kind of transaction. Yeah, but still if you want to provide me something, I will support it without any issue. Yeah. So here it says method B, if it gets a transaction from A, so it will keep using it. It won't say you anything. In case method A was a simple method, from there nothing came. So in method B also will work without any transaction context. Neither a new one will be created nor any exception will be thrown here. Yeah. That's what we mean as supports. Next one is not supported. I hope it is going to be the reverse of the upper one. So here it says that it doesn't need the transaction context, which means it is not at all going to support. So simply that means that if you are getting from method A, then it will be suspended, like requires new was suspending it. This is also going to suspend, and then it is going to work without the transaction context. And in case if nothing is going to come from method A, then it's even much more better, because then it will keep working as it is. Yeah. Now the next one is mandatory. So now let's see how this mandatory is going to be different one from the required, because in general English many times we simply just keep on changing these two words, required and mandatory. But here let's see how it differs. So it says that it always needs a transaction. What does it mean? So it means that if it gets something from method A, then method B will keep using it because it needs. In case if it doesn't get anything from method A, so let's assume method A was not having any kind of @ transaction. In that case, your method B is going to throw the exception that okay, I need one but I'm not having. You will say okay, why don't you create on your own? So it will say that okay, then go for the required annotation. Why do you want me to use? Okay, so mandatory means if it is there it will keep using. If it is not there, an exception will be thrown that transaction is not available, something like this. Yeah. Then next one is never. Now what never means is that it never works with the transaction context. You say okay, it sounds to be almost similar like not supported, because not supported was also saying that I'm not going to support. Yeah, so let's see what never says. So never says that first of all, if you are getting something from method A, so this time I'm not going to suspend it, I'm going to throw you the exception. Why did you give me? I never asked you. Okay, so I will throw the exception. And in case if method A is not having a transaction and nothing comes to B, then I will keep working fine without any transaction. So that is the difference here. Because if you remember in the not supported, it was simply suspending it, but never says I will throw the exception. Yeah. Next comes the last but not the least, nested. So nested in general Java language also, when we say one within the another one. Okay, so let's say what it says. It says it can create a nested transaction context. What it means is that let's say from method A you got a transaction context. Then also method B is going to create a new transaction context, but without suspending the previous one. Which means from method A it got one, and within that transaction context it is going to create a new one. Yeah, so it is neither going to suspend it nor going to throw the exception, but inside that it will be creating. On the other hand, in case if nothing comes from method A, then it will simply create a new one. As simple as that. So I hope now all these 7 are very much clear. Now it doesn't mean that okay Abhishek, which one we should go for. Believe me, like in last scenario, last demo which we did, at that point of time required was enough for us. But let's say when you are working, you may feel that okay, required is not enough, I need to go for any other. Then what simply you need to do is you need to come back here, you need to check the example, understand which example suits you best. Okay, it's not a case that any one of them is going to be always perfect for us. If there are 7, there must be some reason of having 7. It's the same thing that okay, one car cannot be sufficient for each and every requirement. Okay, same thing here. You need to understand, and always you understand that okay, it's not possible to keep doing each and everything with the help of code. So here I thought it's better to explain it with the help of such examples. I hope you find it easier. Next one is let's try to understand the transactional anomalies. Okay, so first of all, let's see what it means. So if you remember in chemistry, we used to have this word anomaly. Okay, so we used to say that okay, there is some anomaly in molecule or some other particular kind of substance. So this anomaly basically means some kind of defect. Okay, so here this anomaly relates that there is some defect whenever multiple transactions are going to work parallelly. So earlier we were calling method B from A, but this time there is something, let's say method A, and then there is something like method B. Both of them are independent of each other. We are not calling B from A or something A from B. Both of them are independent. The only thing is that since it is your real world application, so at the same point of time, someone invoked method A, someone invoked method B. So there were two different invocations, one to method A, another one to method B. And because then two transactions were working in parallelly, so some kind of defect was raised here. Let's see what were these. So here we say there are three types of anomalies. Yeah. I mean, here for this, you don't need to mention anything in the @ transaction. These are the defects. So first of all, we will try to understand these three types of defects. Then we will see how we can resolve these three types of defects. Yeah. So the first defect which we say is the dirty read. Now for each and everything, let's try to understand a scenario first of all. Then we need to perform a process in order to regenerate this kind of anomaly, and then we will see what is the result. Yeah. Now listen here that we are not going to resolve this anomaly as of now. As of now, I'm just telling you the problem. So these are going to be three different problems. Solution we will discuss after this three anomalies. So the scenario for this dirty read is that let's say there is a method A, which we just now saw, there is method B, both of them were having @ transaction. It doesn't mean what propagation you are using because they are not directly interacting with each other. Yeah. So both of them are working and they are working on the same row in the database. So there is a big database, within that there is a particular row, both of them are working on it. Yeah. When I say working on it, it can be something like they are updating the same, they are deleting the same, they are reading the same, it can be anything. Yeah. Now method A starts the transaction and updates the rows value from 100 to 200. Yeah. So let's say it reads the value in A, in that particular row there was some value, and then it is going to update the value to 200. But as of now the method A is not yet completed, so that means it has not committed the change. But this value 200 is going to be available in your persistence context, which you remember it is going to be like your cache, okay, primary cache. Yeah. And our full code is going to make usage of single primary cache, single persistence context. So in the meanwhile, before A completes, method B also reads the value. Now because that particular row has been taken in the persistence context, so method B, instead of actually hitting the database, it will simply read from the persistence context or that particular cache. Now in the cache the value is 200. In database still it is 100, but in the cache it is 200 because method A was about to save. Yeah. So method B will read the value and method B will return 200. Now in the meantime, method A will roll back the change, which simply means that again still the value in the transaction context, I mean in that particular persistence context as well as database is still going to be 100 only. But in the meantime, whosoever invoked method B told them that okay, in the database the value of balance is 200, which means method B is going to provide us the wrong information. Okay, so hence we call it as a dirty read, because it gave me a value which was not actually there in the database because it read quickly from the persistence context only. The benefit is that okay, it was too quick. Okay, it didn't made a connection with the database and just provided you the value quickly. But the problem is it gave me a wrong value. Why wrong value? Because method A roll back that particular thing. So that we call as dirty read. Yeah. How to resolve we will see later on. Now the next one is non-repeatable read. Now let's for this create a scenario. So again method A and method B are working on the same row, but the point is they are getting invoked at slightly different points at time. When I say different point at time, it doesn't mean that okay, one was invoked in the morning, other one was invoked in the afternoon or something like this. It is like we can talk in some terms like milliseconds or nanoseconds, something like this. Okay, so one was invoked at 1 millisecond, another one was invoked at 3 millisecond, something in that particular terms. Yeah. So let's say method A will start the transaction and method A is going to read the value as 100 because 100 was there in the database. Now meanwhile, method B will also get started, a separate transaction will start and it will update the balance to 200. And this time it will even commit in the database. So method B has updated the value to 200 in the database. Now after this, method A there was due to some XYZ reason within the same transaction itself. So within the same call itself, you were rereading the balance from the database. Many times it happens that okay, in your single method there are something like 10 or 12 lines of code. So sometimes you read the value in line number 1, you perform some operation, and then again you want to read the value before doing anything in the database from the again. Yeah. So in this case, method A rereads the value, and now it says that okay, now the value is 200. I mean, I just now saw value was 100, but now it is 200. Okay. So this we call as non-repeatable read, because in this case method B A will get confused that okay, how is it possible? I mean, just now I saw it was 100, now it is 200. Yeah. And the record is single only. So for single row there are two values, which is logically not possible, but method A did just something like this. Okay. So this we call as non-repeatable read, and in this case also, I mean, there are sometimes some issue, but logically if you think, this is not an issue as such, because earlier when method A read, it was 100, and meanwhile method B changed it, so method A, it will be 200 only. Okay. So it's not an issue as such, but then who is going to trust method A? Is it 100 or 200? Yeah. So that's what we call as non-repeatable read. Now the next issue and the third issue, which we call as phantom read. Okay. Now from this, do you remember there was a movie also, Phantom? I mean, what do you remember? Like, what was the star cast of that particular movie? Who watched that particular one? I didn't watch that. Okay. But still, I remember there was a movie, Phantom. I guess Saif Ali Khan was there in that particular movie. I don't remember the whole star cast, or maybe even I'm wrong. Yeah. But it was there. So for phantom read, let's see what's the scenario. So for this, we will say that okay, there is a method A, there is method B. This time they are not going to work on a single row. Instead, they are going to work on a particular set of rows. So this is a difference. Otherwise, you may feel that okay, it is still same like non-repeatable read. But the difference is dirty read and non-repeatable read condition was they were working on a single same row. Phantom read is working on a set of rows. So for this, the process is that first of all, method A will start the transaction, and let's say there is some requirement, some kind of select statement that we are saying that wherever the balance is more than 100, fetch all those rows. So in the database there were only two rows whose balance was more than 100, so method A is going to return you those two rows. In the meanwhile, method B is going to create a new row also, or let's say it has deleted some row, and hence after a new row creation, another row got created and its balance is 200. It was also committed. Then method A is again going to requery the same within the same transaction. So when method A is going to requery the same, it will say that okay, now there are three rows. Okay. So you see, this is again similarly like the previous one, because in the previous one the balance was suddenly got changed because in between method B changed it. Okay. But earlier it was on a single row. Hence we call it as non-repeatable read. This time it is on a set of rows. Okay. So initially when it read, there were two rows with more than 100. Now there are three rows with more than 100. So this we call as phantom read. Yeah. And here why do we use the word phantom? Because when method A is going to requery the balance, it will see okay, there is a phantom row, because this row was not available few milliseconds back, or few milliseconds back this row was not even existing, and now it suddenly came. So it may be something like a ghost or a phantom, and hence we say this is going to be a phantom read. So these are the three problems which happen sometimes when we are working in the real world application. Okay. And basically here when I say real world application, I don't mean to say that okay, our Pakistan is not going to be a case. But the point is that as of now in the Pakistan, we are providing the input with the help of the keyboard and something like this. So at a time only one value can be entered. But whenever it will become a web application, multiple requests can occur at the same time. Hence at that point of time, we may even need to go through the code and make some kind of enhancement. So as of now, we can read. Later on when we will be requiring, you can support me, you can tell me which one needs to be done. Yeah. Next. The next one is isolation here. So what is isolation in @transactional? So the isolation, you can simply assume that it is going to be a solution to avoid the anomalies which you just now saw. So remember we saw the three anomalies: dirty read, when we were reading the value which was not yet committed; non-repeatable read, we were rereading the value and it was getting changed in the row; and then it was the phantom read, when the number of rows were changing for that particular condition. Okay, now with this, now let's see. Now again, the same scenario, method A, method B. We are not saying method A is getting invoked from B or B from A, something like this. But by default, the isolation level is always going to be isolation.default. For propagation, you remember it was propagation.required. For isolation, it is isolation.default. Yeah. And when in the previous time when we used in our code, we were basically making usage of isolation.default. And in isolation, there are again 5 types of isolation, guys. Yeah. So let's see what are these 5 types of isolation and which one we should use for. I mean, which is a solution which can solve all kind of anomalies. And if there exists a solution which can solve all anomalies, why don't we always keep on using that particular solution only? We will see all these things now itself. Yeah. So that means only 5 more slides are going to be there. So again, as the name suggests, first one is going to be default, which is also the default one in nature. Okay. So here I say what default basically means. Default means that, okay, we are not going to set any particular isolation in the code. Instead, depending on our database, we are going to use the isolation, which simply means that, let's say, I mean, these words you are going to read in the next slides, that, okay, there is a repeatable read isolation, read committed isolation, and something like this. So we are going to read in the upcoming slides. So let's say MySQL says that by default, I will be having the isolation level of repeatable read. Oracle, PostgreSQL, SQL Server, they say that for us, by default, it is going to be read committed. So now if your code is working with the MySQL database, so automatically it will be making usage of repeatable read. So if you remember, we were working with the MySQL, so we were automatically making usage of the repeatable read. But in case if someone works with the PostgreSQL, they are by default making usage of read committed. Okay. So here the benefit is very simple. That is that you as a developer, you don't need to worry what isolation level to go for. Okay. But the problem is that here every database is going to have its own isolation level. So let's say that today I'm making usage of MySQL, but later on after some time I plan to switch to PostgreSQL. Although most of the things, most of the queries, everything will remain same, but I may need to make some changes in my code related to @transactionals. Okay, if required, because in MySQL it was repeatable read, in Postgre it is read committed. Okay, or it may be a vice versa or something like this. Okay, so here you are completely dependent on your database. And if you don't know, okay, which particular kind of isolation your database is using, then you may end up in some other issues also. Yeah. So and hence it is many times very helpful, first of all, to know that, okay, which database you are using, which isolation your database is using. So easily if you will Google, you say what is the default isolation level of Oracle or SQL Server or something like this, you will get the answer very easily. Okay, but that is the simple meaning of default. So which means that since we were using MySQL, so we were using the repeatable read. Now next one is read uncommitted. Okay, which we can provide. Let's try to understand what do we mean by this. So this read uncommitted, I mean, from the name itself, it is very clear that I will be able to read a value which is not even committed in the database. Okay, so you will say, okay, if this will happen, then it will still lead to the problem of dirty read. Agree or not? Because method B can read a value which is not in the database but just in the persistence context. So that's the meaning of it. And still that means the problem of dirty read is going to exist, and hence we say this is the lowest level of isolation, guys. Okay, below this we don't have any other isolation level, and the thing is that it's neither going to solve your dirty read, nor non-repeatable read, nor the phantom read. It is going to be a very basic one. The benefit is it is going to be very fast. Okay, because it doesn't need to work with all these problems, hence it is going to be faster in nature. Now the next one is read committed. So again, as the name suggests, this time it says that I will only read the values which are committed, which simply means that it is going to avoid the issue of dirty read, because it will only get the values which are already saved in the database, not any other value from the persistence context. So that means dirty read issue is resolved. But since it is going to read the committed value, so now if you remember, in non-repeatable read, there also the value was committed. In the phantom read, the value was getting committed. So which means that those two issues are still going to remain here, non-repeatable read and phantom read. Okay, it will only resolve your dirty read issues. Next one is repeatable read. So here from the name itself, it very simply says that okay, there was an issue of non-repeatable read. My name is repeatable read, so I will resolve that issue. Okay, so this is going to resolve dirty read as well as non-repeatable read. Okay, I mean, although in the description I haven't mentioned explicitly, but again, repeatable read will read the committed values only, but still somehow it is going to resolve the issue of non-repeatable reads. Yeah, so two issues are solved, but still phantom read problem is not yet resolved here. Yeah. So now the last but not the least is serializable. So I mean, this name is going to be little bit different from others, but the point is this is the highest level of isolation, and hence it is going to resolve the issue of dirty read, non-repeatable read, as well as the phantom read. So now you will say me that okay Abhishek, that means all our problems got solved, and from now onwards we will just keep on using serializable. But believe me guys, that is not possible. Okay, because just assume in the real world there are so many cities. I mean, some city we say is very polluted, some city we say it is that particular city is green, some particular city is expensive, but some cities are very beautiful. But does that mean that everyone can sit or everyone can stay in those beautiful cities? The answer is no. If a particular city is very beautiful, that means it is going to be very costly also, or there may be some other issues related with that particular thing. Okay, so the life is not that simple. Same way in Java, things are not that simple that now you will simply making usage of this serializable. Okay, because it will say that if I will resolve all the issues, then also I am the highest level of isolation. So that simply means that it is going to be serializable in order. Hence, if there are multiple transactions, then it will force them to perform in the sequential order. So that simply means if there are, let's say, 3 requests are going to come, so it is going to resolve them one by one, not parallelly. Okay, because it is going to lock, it is going to block your resources, and hence only it is going to resolve the other issues. So that doesn't mean that every time you should go for the serializable. Otherwise you will find that okay, your application is working very slow. Okay, so again here we need to decide as per the problem that which particular isolation level is going to be best for us. Are we able to survive with the dirty reads? If you say that okay, I'm fine with dirty read, non-repeatable read, and phantom read, believe me, read uncommitted is the easiest and the fastest one, and you should be using it. But you say that okay, no, I'm fine with a non-repeatable read or phantom read, but at least dirty read I'm not fine with it. Okay, because for dirty read, what's the proof? Like there was nothing in the database, you still read it. So then I will say that okay, go for read committed or something like this. Okay, so again you need to balance out that okay, how much problems you can face, okay, how much problem is fine for you, and which solution is fine for you. If you say no, I want to resolve all the problems, then it is going to be little bit slow in nature, it is going to reduce the performance a bit, and then you should be fine with that particular one. Okay, I mean, everything is not possible at a same point of time. So that's the meaning of all these isolation levels in nature. Okay, so hence in this video we saw what are the propagation types, what are the anomalies, what are the isolations. For this I assume that you will also say that okay, there was no need of having the separate code as such, because in the code we just need to make some changes, and most of the things are that okay, it may happen that it may never ever come in your life when you are coding, but it may happen that they will just come in your next particular task itself, that you will get a Jira ticket, and in that Jira ticket you need to resolve a particular kind of problem like this. Okay, so at that point of time this video is going to be very helpful for you. Yeah, and rest of the way of using the annotation was very easy, you have already seen in the previous video. So I hope you are going to like it. If yes, do like the video, do comment something, do share it with your friends, and see you in the next video guys. Bye everyone.